Yes, now today we'll start with the classification of the metal alloys. And in major classification of the metal alloys, we have ferrous and non-ferrous alloys. But in our industry, normally the maximum use throughout the world in industrial sector is still the iron or ferrous alloys that contains cast iron and steel, mainly these alloys. So we discussed the classification of metal alloys as ferrous and non-ferrous alloys, and then ferrous alloys will be majorly classified with the steel and cast irons. In cast irons, we have gray cast iron, white cast iron, ductile and malleable cast iron, nodular cast iron. Just like these are some types of cast iron. And with the steel, we have either low carbon steel, medium carbon steel, and high carbon steel. And also there is another type which is called as stainless steel. So there can be a high percentage of alloy or there can be a low percentage of alloy. Okay, now we go on with the production of iron. Iron we know that is occurred naturally in the form of iron ore, and then we have to separate this crude form of iron which is called a pig iron in blast furnace either by a cold working process with a route iron, or we have to melt it and poured into sand mold in the form of cast iron or a mild iron or a steel as in the form of alloy. These irons available in the iron for in the form of hematite, magnetite, limonite, siderite or pyrites. So hematite we know that is the alloy of iron oxides, and magnetite also the alloy of iron oxide, but with the hematite it has 70% of iron and magnetite has 72.4% of iron content in that. So these are actually the most rich iron containing alloys, iron ores that are present naturally. Then we have limonite, which is actually the aqueous solution of iron oxide, which contains 60% of iron. Then siderite is iron in the form of with the iron carbonate and with the iron sulfide in the form of pyrite. So just go on with this because not much things to understand. Just you can read and you can memorize it. So iron ores are the rocks and minerals from which metallic irons can be extracted. The ores are usually rich in iron oxides and vary in color from dark gray, bright yellow, or deep purple or rusty red. And the iron usually found as the nomenclature is here with the iron ores in the form of magnetite, in the form of hematite, and the magnetite have color of black oxide, and hematite with the red, brown, and black oxide. And maybe it's a limonite, siderite, and iron pyrite in the form of yellow colors. And there are in different locations. These iron ores are present. Percent locations are also given in the form of table here. So go quickly, and then this iron actually from when we extract from the iron ore, we have to convert it into a pure iron form. And when we want to convert it, we have different kind of furnaces we used. There are some puddling furnaces, cementation furnaces, Bessemer furnaces, open arc furnaces, basic oxygen furnaces, electrical arc furnaces, and blast furnaces. And most commonly used are blast furnaces and puddling furnaces, and they are also cheap way to extract the iron. So this is cementation furnaces also shown here. Go on, just you can see Bessemer furnaces. These are arrangement of these kind of furnaces. Then this is open earth furnaces, basic oxygen furnaces. This is electric arc furnaces, and then we have the production of route iron in puddling furnaces, as you see here. So, okay, I will go on with this. This is a puddling furnace and the most ancient one and the cheap one. And then the production of iron in the blast furnaces also quickly. Quickly, we will see that this is the arrangement of the blast furnaces. We have on the down, we have molten iron, and the slag is also collected on the other side, and on the one side with the molten and other side with the slag. And then we have a preheated air, and within the blast furnaces, then we have also on the top we have coke or limestone or gases that came out of the upper chambers in the form of carbon monoxide, carbon dioxide, and nitrogen gases. So these are actually the harmful exhaust gases that came out of the furnace, and they must be converted, especially carbon monoxide, that must be converted into carbon dioxide, the less harmful gas. So iron, from iron oxides, we know that it must be reacted with carbon monoxide, and these are the reactions are also given on the right side of the table. And with the production of carbon monoxide, we can produce from calcium carbonate, and with the calcium oxide reacted with silicon oxide, we can produce carbon monoxide. And this carbon monoxide will be used to extract the iron from the iron ore. Actually, we have to produce carbon monoxide first, and then fed with the iron ore to extract the iron from the iron oxide ore, which is maybe a hematite or magnetite ore. Okay, now we go on with the blast furnace. Okay, you can, these are some waste gases here, and we can have the slag can be collected and molten iron can be collected on the other side. So it's like this. And the famous classification, we know that in the iron, either it's a cast iron or a steel, and the cast iron actually have the more iron, carbon rich contents in the cast iron, and it means that more carbon means it is more brittle in nature, so it's difficult to machine that kind of iron because of its brittleness properties. So we normally, what we will do, we will melt it, and we and with the help of mold, we can produce the things from that cast iron. But this is a very important and commonly used iron metal we will use commonly, this cast iron. Okay, and the ferrous alloys normally with the percentage of 2.1% by weight of carbon, more than 2.1%, we called it as cast iron. They are have low melting point, so they can easily be melted, so they can be casted, and also the brittle. So its cementile decomposes into ferrite and graphite. Ferrite is actually alpha iron. This is the first form in solid form we could found with the iron, because if you see in the iron carbide diagram, it start with the ferrite. Okay, which is alpha iron, first form of iron. Now the, okay, you can have this explanation of cast iron. These are the class of ferrous alloys with carbon contents more than 2% or 2.14%, and in general, but however, the mostly cast iron contains 3 to 4.5% by weight of carbon in addition to other alloying elements. So these are some properties of cast iron you can easily read by yourself. And so we types of cast iron, we have gray cast iron, we have white cast iron, we have malleable cast iron, we have ductile cast iron, and then we have the compacted graphite iron also there. So gray cast iron, very important. It contains between 2.5 to 4% of by weight of carbon, and 1 to 3% of by weight of silicon. So it's the structure is also microscopic. View of the structure is also on the right. It has graphite flakes, and it's weak and brittle under tension, stronger under compression. So it's good for compression. So normally when there is a compressive load, we use cast iron. It's good in compressive strength. Excellent vibration damping and wear resistance. And the ductile, we can say nodular cast iron, it has an addition of magnesium instead of silicon. So it's graphite in nodules, not flakes. Matrix often pearlite better ductility. Pearlite we will see in an iron carbide diagram. It's also another form of iron because it has ferrite. Then we have cementite, wearite. So these are just the forms of iron, and these forms will differentiate these forms with the percentage of carbon either, or with the temperature. So then we have white cast iron. Just you can read it by yourself. Also, it's very easy. It contains less than 1% of silicon, and uh, For low silicon cast iron and rapid cooling rate, most of the carbon exists as cementite instead of graphite, and structure is given here. Similarly, with the malleable cast iron, you can see heat treatment, annealing heat treatment process we will see in the next slides also. So there are different kinds of heat treatment actually process. Some with annealing, some is case hardening, some is quenching, some is tempering, just like some is spheroidizing. So for each heat treatment have different effects on the metal. So it can be more malleable or it can be brittle. It actually imparts some. This heat treatment actually imparts some properties on the on the metal. So, in malleable cast iron means more ductile in nature. It's because of the after extraction we have done some heat treatment on that metal or on that iron metal, and then it imparts some kind of properties or mixing with some alloys. Then there is a compacted graphite iron because this was not before, but now it's added in the family, and because it has more silicon content, and silicon content ranges between 1.73% by weight, and the carbon content is normally between 3.1 to 4%. Okay, now now production of cast iron. Okay, we'll see. Not here. We will actually see in carbon diagram, which is in the next slide. So iron carbon diagram, actually there is some solid phase of iron carbon diagram, which is ferrite, alpha iron, which I told you it start with the alpha iron. Then we have gamma iron, which is austenite, then cementite and delta iron. In delta also pearlite, which is a combination of ferrite and cementite. Then we have ludiburite, then we have martensite, and then we have benite. So some in the rod form, some in the plate form, and with the mixing. And the difference between them is the carbon content and the temperature. So just look at the figure here, which is this figure is actually iron carbide diagram, we called it. And on the y-axis you can see the temperatures ranges, and on the x-axis you can see the percentage of carbon, so mass of carbon. And until 2% it is represented as steel, and if it's more than 2.15, exactly you saw it there, is more than 2%, we considered it as more brittle. As the percentage of carbon increases, the iron becomes more and more brittle, and have low melting point, so it's good for casting purposes. But before that, it is good for machining purposes in the form of steel. Okay, just go to the next slide uh, to explain this whole iron carbide diagram. Let me share.